Hello Internet and welcome to a new Blender video. Today we will break down the modeling process in Blender into individual steps. On this basis you can follow the process and develop your own similar models. The video is showing a modeling process of a phone holder for a dashboard in a car. The goal is to create a model that is ready for 3D printing. This includes precise modeling techniques with defined model dimensions, a good mesh topology, and also the final correction of any errors for 3D printing. But enough words for this introduction. Let's start with the modeling and see how we can create models for 3D printing in Blender using precision modeling techniques. I start by cleaning up the scene and deleting the camera and the light source from the view. I will not need both objects because we do not want to visualize anything. Then I adjust the measuring system in the scene settings. In my case, metric with millimeter as a unit. This also includes that the size of the viewport grid should be set to the same scale, so you can use the grid snapping to model exactly, using the orthogonal perspective and absolute grid snapping. I set the clipping of the view to 100,000 millimeters so that nothing is hidden when I zoom out a little bit more. Keep in mind that the grid scale and the view clipping is workspace specific. So if you work with layout and modeling workspace, you have to set it in both workspaces. In addition, save this as your default setting if you want to use this setting most of the time. Spend some time to sketch your model to save time overall. A short sketch is quickly made and the measurements are noted down. This helps to organize your thoughts and ideas. It is important to understand the structure and topology of your model to create the appropriate model structures. This way there is less complex editing and less repairs in your model, and you can reach your goal faster. I will use the topology and structures that I found in the sketch to decide which basic shape I will use as a starting point and where I want to place my loop cuts later on. I use a cube mesh as a starting point and set the inner dimensions. These are the dimensions of my phone with a small addition so it is not too narrow. It's a good habit to apply rotation and scale after you change them in your model, because otherwise it could lead to different problems with modifiers or other blend functions afterwards. With the cube and the inner dimension in place, we can create the foundation of the required mesh topology. Therefore we can use the loop cut tool to slice and dice or project into the necessary topology that we use for modeling later on. Switch on absolute grid snapping and go into the orthogonal view. Now you can move your loop cuts very precisely and use the grid for snapping. Using the Ctrl key while moving the loop cuts gives me the possibility to move exactly one grid dimension up or down or left or right, depending on the direction I pre-selected. Another important rule for Blender precision modeling is to pre-select the direction if you move, extrude, scale or rotate any element. Use the shortcut keys to restrict the direction you're going to use for your current operation. Now I delete unnecessary geometry to create the basic shape for my phone holder. The idea is to use the solidify modifier to thicken the walls later on. Now we have a hollow model and we can use the solidify modifier to give the wall some thickness. Here I expand the wall size by 2 mm to the outside. Finally, we create some more geometry for the mounting bracket. To make sure that our model is true to size in certain places, we can use the Measure It add-on. This gives us the possibility to measure our model permanently. To model the mounting bracket, I extrude and move the dependent geometry parts. Thereby, I make sure that I have always restricted the direction of movement in advance. Alternatively, once I have selected the operation and the direction using the keyboard shortcut, I can also enter the movement and distance directly via the keyboard. Entering the distance directly from the keyboard is a very accurate method of positioning. Another possibility is to enter the transformation values directly in the item transform dialog or in the dialog that appears with each transformation. A very fast and precise modeling technique is to use the snapping mode in combination with absolute grid snapping. So every time when you're in the orthogonal perspective, you can use the mouse in combination with the keyboard shortcut Control, and you can move your selected items in absolute increments related to your grid dimensions. In my case, I set the grid dimensions to 1 mm, and if I zoom in into the grid, I have 1/10 of a millimeter. With this in mind, I can very fast and precisely position my elements during the modeling process. Here's a very typical workflow that I use during modeling. I use the Measure It add-on to measure the distance between two vertices, an edge or an angle. And then I modify the related geometry. For example, I move or rotate or scale the related geometry. The mounting bracket is conical and has a 15-degree inclination. Also here I use the Measure It add-on with the function to measure the angle. To rotate the mounting bracket, I position the 3D cursor on the pivot point and set the pivot point settings in Blender to use the 3D cursor. Then I activate the X-ray mode, select the geometry of the mounting bracket and rotate the geometry to the desired angle. As you can see, the Measure It add-on can be very helpful. You can set measurements, they are connected with the model, and then you can manipulate the model and you can still see how this affects your measurements. I use the viewport overlays in edit mode to make the normals visible. This gives me more information where my faces are directed to and what's inside and what's outside of the model. If we now activate the Solidify modifier, we see that also the mounting bracket is affected by the modifier. But this is not intended. In this case, we have to exclude parts of the geometry or parts of the mesh from the Solidify modifier. Therefore, we create a vertex group including all the geometry we want to be affected by the Solidify modifier. And then we set this group in the Solidify modifier as the group to work with. Now we will smooth some of the sharp edges a little bit to make the overall look a little bit more pleasing. Blender offers the possibility to call the bevel tool for single vertices with the keyboard shortcut Shift-Ctrl-B. Now you can use the mouse like with the normal edge bevel tool or select the dialog to enter the parameters. Among other things, the radius or subdivisions and other parameters can be set. You can activate on cage icon in the modifier dialog to show the vertices that will be created by the modifier. This gives you a better overview of the geometry that will be created later on. There are many possibilities in Blender to round the edges of a model or to smooth the whole design. Two possibilities come immediately to my mind. First, the bevel modifier, and second, the subdivision modifier. Both modifiers are non-destructive. This means you can play around with different settings and parameters to show what it looks like without changing your model permanently. For the subdivision modifier, we need to create some additional geometry in the model to limit the space for smoothing. For example, in my model, here I want to limit the radius at the corners on the inside of the model, and therefore I insert additional loop cuts. For the final editing and the cleanup, we have to apply the Solidify modifier. To do this, we go to the modifier dialog and apply the respective modifier entry. goal was to design a model for 3D printing. For this purpose, any errors in the model must be removed to complete the design. The add-ons 3D Print Toolbox offers some tools for this, especially to find non-manifold areas or non-planar triangles in your model. Additionally, duplicate vertices should be found and deleted. The normals of the faces should be correctly aligned and point outwards. These errors can cause big problems for 3D printing. Although many smaller problems can be solved by current slicer programs during the slicing process. Some of the errors in the model can already be corrected explicitly by special functions of the slicer programs. In addition to the 3D Print Toolbox add-on, you can use the mesh cleanup functions to correct particular errors in your model. For example, to delete duplicate vertices. There are some failures in our model generated by the solidify modifier in the transition between the body of the model and the mounting bracket. To fix that, we have to correct the mesh manually, and according to this we can use the 3D Print Toolbox to identify any failures in the overall geometry and use the mesh cleanup functions to get rid of these errors in the geometry of our model. Here I need to correct the position of these two wrong-placed vertices. Therefore I use the orthogonal perspective and the top view. Now I select the move function and use the mouse to drag the pre-selected vertices, but now in combination with the shift key to place the vertices freely and match the shape of the body. Now it's time to smooth our model using the subdivision surface modifier. I assign the modifier and use a subdivision level of 3 to 4. I will not overdo it here because any additional subdivision surface level will add a huge amount of vertices to the final model. And my slicer program has to handle this huge amount of vertices afterwards, and this could lead to additional problems, to long processing times, and beside of that, my printer can only print to a certain amount of detail. So depending on the printer and the printer settings that I choose, but there is a threshold, and below this threshold I cannot print any finer details. Even I have them in the model because the printer is not able to handle this. After I was satisfied with the model, I exported the model using the Blender STL file export function. The settings can be seen in the video. I don't apply the modifiers before and do it during the export in one go. I loaded the STL file into my slicer program to calculate the final print model. Here I use Cura with the settings for my 3D printer and for a PLA Plus filament. The settings for printing can be seen in the video, but later on I decided to use an 0.28mm layer instead of an 0.2mm layer because the printing time was very long. I have set the temperature a little bit higher to get a good layer binding, and in addition I have chosen a wall thickness of 1 to 2 millimeters and an infill of 35%. This should allow the print to withstand the mechanical stress. I positioned the print flat so that the print layers are at a 90-degree angle to the load forces acting on the phone holder. That's all for today. At the end, some pictures and videos how the phone holder looks in the car. But for me, this is more a use case to show some different methods of modeling. I will follow this topic in the next weeks and show other methods of modeling using Blender based on this use case. For example, using Boolean methods for shaping, we will use snap joints and some nice surface techniques that will make our model unique. Let me know your questions and ideas about this and leave them in the comments. And of course, push the like button to support my channel. Enjoy the work with Blender and thanks for watching. Bye, Friedhelm.